The Raspberry Pi 3 Model B is the latest generation of Raspberry Pi, offering makers, enthusiasts, educators, and professional engineers a low-cost, high-capability computing board with the highest level performance, connectivity, and power management. Raspberry Pi 3 Model B is built on the powerful next-generation BCM2837 64-bit quad-core processor from Broadcom and runs at a super-fast 1.2 GHz. The new Raspberry Pi 3 comes with built-in wireless and low-energy Bluetooth connectivity, making it the first Internet of Things-ready Raspberry Pi. These enhancements make the Raspberry Pi 3 Model B the fastest, most powerful Raspberry Pi available today. To support more powerful external USB devices, the power management of the Raspberry Pi 3 has been improved with an upgraded 2.5 amp switched micro USB power source. The Pi 3's form factor is identical to the Raspberry Pi 2's, and the extended 40-pin GPIO header is backward compatible for easy use on Pi projects and HAT products. The most significant physical difference between the Pi 2 and the Pi 3 is the position of the status LEDs. Other popular features of the Raspberry Pi 3 Model B include a full-size HDMI port, 4 USB 2 ports, a micro SD port, a 4-pole stereo audio and composite video port, a CSI camera port, and a DSI display port. The improved features of the Raspberry Pi 3 promise to help you develop new, exciting, and inspiring applications such as IoT connectivity, Bluetooth streaming to headphones or speakers, Wi-Fi gateways, home cloud storage, and more.
People have been doing single-threaded computing, having one processor running one task at a time, and that's worked great. But then we hit a frequency wall, and then we hit a memory bottleneck, and things just stopped. So what we've seen for last year, really performance hasn't improved as much as it should. We're now stalling, and if we don't do anything about it, all those great strides we made over the last 30 years, when things would get better every single year, they're going to stop. And the answer to that is parallel computing. It's the only way to really scale in terms of energy efficiency, performance, and cost. I've been in the chip industry for 15 years, founded a company in 2008 called Adaptiva, and we've been designing parallel chips, and that's what we do. We're hardware designers. We love designing chips, low power, they're simple, easy to use. We've been doing this for 4 years now. Had great traction in government labs, corporate labs, universities. The obstacles to really make parallel programming ubiquitous and everywhere is you need available hardware that's parallel. That's the first step. It needs to be open so that people can really study it and understand it. It can't be a black box that you give some work to and just does things magically. And with time, things have gotten more and more closed down. When you close down the system, really what you're asking for is for a company to do all the work for you or most of the work for you. You get a sandbox to play with and basically are told, don't try to think, don't try to innovate and make it better. If you do open up the architecture, somebody will come up with a better way of doing things. It's worked great for open source software, right? I mean, over the years, and we want to do the same thing for hardware. If you're going to have a very expensive platform that's closed source, that is tied with NDAs, then you're only going to reach a very, very small audience. We're going to provide a $99 kit that's going to be completely open source tools, free tools, lots of performance. And we think that's really going to enable the next level of computing and educate the masses of how to do parallel programming.
With this kind of processor, I can really stretch the kind of research we are doing, implementing, say, optic flow or visual information relating to changes in the visual input as you move around. If the hardware is not powerful enough, the frame rate at which you can calculate the image is too low for a robot, for instance, to navigate efficiently in the environment. So having lots of powerful processor will give us the chance to implement optic flow, object recognition, navigation, path planning, higher cognitive functions, a variety of things that today we cannot even dream of because there is not enough computing power.
Our first audience are the developers, the guys who really want to study parallel programming, maybe the guys who want to create a great application but doesn't have the performance to do it today in an embedded environment. But the second tier after that is the guy who just wants an awesome computer for $99 that has more performance than anything else out there. We've had lots of people interested in our platform, but our price point has turned them away. Thousands of dollars today is too much for somebody to do research. Everybody is constrained by cost, by their funding. Anybody should be able to afford a $9 kit if they're doing research. Big thing about making the kit cheap enough is this idea of producing a chip in volume. And for that we need money. So we build prototypes today that are fully functional products, but we just don't have the tooling, the factory set up to produce these things for a couple of dollars. Today they cost a few $100s. With this funding, we can bring it down to a couple of dollars per chip. If you want this platform, we're asking you to basically pledge to the Kickstarter project, and that's going to enable this to bring our price point down to $99 and really make an open platform. In return, for that favor, we're going to open source all our software, give it away for free, and open up all our documents and architectural reference manuals on the web. Getting the platform out there, we can put it in anybody's hands to innovate, to solve the parallel computing problem together.
Hello, we're the team of Blackswift, powerful, tiny, affordable and wireless computer. When we say tiny, we mean coin-sized. When we say affordable, it means that it costs only $25 and wireless because it has an integrated and ready-to-use Wi-Fi adapter. And it's not yet another Arduino, it's a computer with Linux-based operating system and 400 MHz 32-bit processor core. There are already many small-sized computers such as Arduino, Raspberry Pi, Carambola, etc. You may ask why we decided to make Blackswift. Well, we're not happy with the existing solutions. If you look at them, you can divide them into two groups. First, designed for enthusiasts, which are relatively big and full set of connectors on board, it's Raspberry for example. The other group is designed as an embedded solution for professionals. It is much smaller, without unnecessary components but unfriendly to novice users. Usually you need some kind of motherboard just to power it because there are no ordinary connectors at all. So we decided to combine the best of both worlds. Create a computer with both professionals and enthusiasts in mind. Make it simple, easy to connect, easy to develop, and at the same time ready to use in professional-grade embedded applications. And with the onboard Wi-Fi, of course. By the way, Raspberry likes it. This is how Blackswift was born. It is really tiny, comparable to SD memory card size, and has two micro USB connectors and integrated Wi-Fi antenna. So to start using it, you need nothing but micro USB power adapter. A cell phone charger will do. Blackswift can be used standalone and easily integrated into your own device or some existing home appliance to make it smart and connected. It has two connectors to attach it to motherboard with peripherals you need. You can solder it or make it detachable, align with the main board or set it at 90 degrees to it. And we want to share it with you, not just sell it, but literally share. Blackswift is open source hardware. It is not only based on OpenWRT operating system, but we will provide schematics and all the information needed to make it. But enough specifications, let's see how we can use it, a few fairly basic examples.
Easiest way to use Blackswift is to use it standalone. You have one micro USB to power it and another to connect some peripherals, be it web camera, audio card or external storage. So let's make, let's make wireless music player. I have loudspeakers I never use, I have home network storage where all my music is stored as MP3s, and I want speakers to play it. All I need here is Blackswift, some 5V power adapter, USB sound card, OTG adapter and 5 to 10 minutes. Connect all the parts, log into Blackswift shell, install some software packages, Samba package to access network storage and MPD to play the music. To control the player you can use application on your Android device or PC or Mac or iPhone. Next level, when you have played enough with USB devices, to assemble some basic peripherals, for example relays or something, and connect it to Blackswift's GPIO. You can do it with a breadboard or Eurocard board. By the way, did you notice this Christmas tree? I know, Christmas was a long ago. I just want to show you the device that controls its lights. Yes, it's Blackswift. And half-bridge driver with a bit of resistors and transistors around it on a small board. It has several modes, brightness and speed control, and absolutely the best thing here that I am able to control it without getting out of the bed. I am joking a bit of course, but this project is a good example of what you can make with Blackswift on the weekend. And the last project is a kind of professional design. It's an energy meter built in a case of differential current device, so it can be mounted on the standard DIN rail and will measure your apartment's power consumption in real time with all the nice graphs and accumulated data. Probably your energy company would never allow you to pay bills according to your own meter, But anyway, it's nice to know how much your air conditioner or washing machine may cost you. Or am I just a control freak? And the best thing is that we created all 3 projects, very different projects, using the same board, Black Swift. It means that with it you can grow, you can raise your experience in electronics, starting with simplest examples and up to professional embedded development. With the same board, same components. Isn't it great?
And now let's introduce the members of our team. Unfortunately, we're a bit spread all over the world, from Russia to New Zealand. That's why we cannot be all here now.
I'm Dmitry, Black Swift project leader. I am 7 years in professional electronic development. We always needed modern computer core for our devices, so Black Swift is the project I created for myself as well as for everyone else. As they say, if you need something done, do it yourself.
Hello once again, my name is Nastya and I'm part of Black Swift team. I'm a professional linguist and marketing manager, and in our team I'm responsible for marketing. It has become a great experience in my life to be part of this project.
Hi, I'm Oleg. I'm responsible in our team for marketing strategy and public relations. And for me, it's not just some professional experience. In fact, I'm just having fun.
Hi Kickstarter, my name is Bruno Sinopoli. I'm a professor in the Electrical and Computer Engineering department at Carnegie Mellon, and I'm here to introduce the Kickstarter community with a groundbreaking project, UDO. With UDO, we want to combine the winning characteristics of Arduino and Raspberry Pi in one single board. The simplicity of Arduino in managing sensors, combined with the flexibility of a microcomputer based on ARM, are integrated in UDO, giving you a powerful prototyping board able to run Linux or Android.
Hi, I'm Marco and I'm part of the team that developed the UDO board. In UDO, 2 ARM CPU live side by side with 1 gig of RAM memory. The board has the same pinout as Arduino Due, ensuring full compatibility. UDO has full HD video outputs with touch display support, Ethernet connections and Wi-Fi module. There are 2 mini USB for programming and debugging and 2 standard USB, audio and microphone jacks. UDO also supports serial ATA hard drive and camera input. The operating system runs on microSD and can be easily switched between Android and Linux.
Hi, I'm Andrea and I'm an interaction designer. When we explored the concept behind the UDO, one of our main concerns was the target. UDO should be for everyone, even for those people without a strong skill in coding and electronics, like me for example. Now, I'm going to lead you through 5 scenarios to show you some of the capabilities of UDO. Let's go! This scenario is very easy. UDO is a Linux computer itself, and you can use the programming language Scratch for Arduino to play with it. Android 4 runs smoothly on UDO board, with a lot of accessories and sensors, such as a touch display and RFID reader, through embedded ADK connection.
Let's get it poppin' with CC Mixer. It's your boy Jeff Williams. Word. What's up, young world? It's Jeff Williams.
And Jay Lang.
You're listening to CC Mixer.
Where it's always in the mix.
With the UDO, everything can be a controller. Build and plug in sensor to Arduino ports and have fun with your friends. UDO is open source. Teacher can easily use it to teach students the basic of programming.
This is a ball and click system. The controller has been embedded in the UDO board. The ball moves according to the chosen reference.
UDO is fully compatible with every Arduino Duo shield available on the market, like the motor shield. Urban furniture becomes smart with UDO, and it's easy to envision new behaviors and services for the object around you.
Radio.
Fighting the world with hard-hitting.
In vain, what about dreams? You know.
Il brutto anatroccolo.
Il brutto anatroccolo.
Che
ti
bellezza
piace?
fuori in campagna. Piena estate. Il grano tutto giallo come l'oro.
We think that the UDO platform is an amazing opportunity for our students to experiment, try and test their designs in an easy and intuitive way.
UDO is a great tool for humanities students that more and more love to be engaged in physical computing projects.
We are very happy to test the UDO board because we believe that it will be very useful for both undergraduate and graduate students for designing and testing control applications.
The UDO platform seems indeed promising for both teaching physical computing and rapid prototyping.
We decided to present our project on Kickstarter because we need help to make this prototype a finished product. The goal of $27,000 will allow us to start production scale while maintaining the low price. Make a pledge and help UDO become a world-changing platform.
Hi Kickstarters, I'm Lauren.
And I'm Matt. We are the Latte team, and this is our latest product, the Latte Panda.
We are makers, we love making and hacking things. But so far, we haven't found any suitable tools for Windows-based projects.
So we created Latte Panda, a palm-sized quad-core full Windows 10 computer, and it runs perfectly with you. Using Microsoft Office, playing high-definition videos, and running other Windows-compatible software on the Latte Panda is exactly the same experience as using a regular PC. And it's way smaller. In fact, it's 40% smaller than an iPhone.
But just like an iPhone, It includes Wi-Fi and Bluetooth 4.0. It's very affordable to run, using a regular 5V phone charger for power. To make it suitable for a wide range of user scenarios, LatiPanda also comes packaged with an Arduino-compatible coprocessor. With existing open-source APIs, you can build your own software or hardware projects and then share them to our community.
We are a small team of engineers and hobbyists based in Shanghai, each with specific skills. Supported by DF Robot, we have an array of hardware and software resources at our disposal. We love tinkering with hardware, and we are very excited to share our creations with you.